Oh, hello again. Still sick. Uh, Making it though. This is for Math 111Z, and this is section 1.5 in our text. This covers linear and quadratic equations. Equations uh, implying that we're looking to solve for x. Right? Um, just like um, just to note that this section is beefy. This is a beefy section. It's got a lot in it. Uh, it is essentially it's essentially half of algebra 2, so in this one section. So um, there's going to be a lot coming at you pretty quickly here, and hopefully it will refresh what you already know from your like Math 95, your algebra 2 from high school. So here we go. Solving for x, something like this. Lots of ways to do this. I would start by distributing the 3. Collect your like terms. Move all the x's to one side of the equation. Doesn't really matter which side you move it to. I tend to move it to the side that keeps the x positive, right? And now we have x equals 4. Right, you can always check your work. Is 3 times 4 plus 2 minus 2 equal to 4 times 4? Is 3 times 6 minus 2 equal to 16? Is 18 minus 2 equal to 16? Is 16 equal to 16? All right, awesome. And moving along here, we have, let's take a look at this one. So I am going to go ahead and solve this equation. I can multiply both sides by a common denominator of 10, which will clear those fractions out. That leaves me with the 5 here. Cancel leaves with 5. And a 2 here. Cancel leaves with 2. And now I'm going to distribute. Collect like terms. All right. And let's see what we got here. Good. There should be a plus 23. Just subtract the 23 from both sides. And divide by 9. And I can plug it into the original equation to check my work. So 8 over 2 plus 5 over 5 equals 5. 4 plus 1 equals 5, and that checks. Awesome. All right. Also, the other linear. When you talk about a linear equation, you're talking about a single variable with a degree of 1, no exponent. Right. I'm going to actually do this problem. Lots of ways to approach this. You can just leave the decimals right where they are. It won't change anything. But you could also multiply both sides by 100 to get rid of the decimals. So if I do that, this goes into this term right here. Becomes 6. I'm going to move the decimal over 2 places. 60. Goes into here. Move the decimal over 2 places. Move the decimal over 2 places. And we end up with this. Right? Notice that this negative went into here, and negative, that's why that's a positive there. And we're going to subtract the 63 from both sides. (117x) equals 63 minus 15. (48), and then divided by 117. And that, as a decimal, just do on my calculator here. 48 divided by 117 is approximately, you can just leave it as a fraction of this too. There we go. All right, so we get that. All right. There's also something called literal equations that we do. That's if you have something like E equals mc squared, but you want to solve for m, you divide both sides by c squared. So you'd have mass equals E over c squared. So it's just moving them away. If you know that the perimeter of something is 15, and I want to isolate the W to L, this is an L, not a 21, then I could divide by 2. My width would be the perimeter minus both sides over divide by 2. All right, so again, this would be considered solving a literal equation. Quadratic equations are second degree polynomials. Quadratic equations are second degree polynomials. That means this would be looking like that. Okay. More standard, you'll see it using these variables for your coefficients. Right. And usually in standard form, this is equal to 0. All right, there we have. All right. All right, so there's several ways you can solve a quadratic. You can factor it. You can complete the square. Or you can use the quadratic equation. Let's do all three of those things with one thing. Suppose I have 2x squared minus 7x plus 3 equals 0. I'm going to solve this by factoring. I know I have to have a 2x and an x. I know these are both minus because this is a plus here, and this is a minus, so these have to multiply together. And I know that the 3 has to go here to give me a 6, and a 1 here to give me a 1. 6 plus 1 is 7 to get me in the middle. I set that equal to 0 to solve. The only way a product can be 0 is if one of its elements is 0. So either that needs to be 0 or this needs to be 0. So either 2x equals 1 or x equals 3. So either x is 1/2 or x is 3. I plug those in. 2 times 3 squared minus 7 times 3 plus 3 is equal to 2 times 9 minus 21 plus 3. 18 minus 21 plus 3. Negative 3 plus 3 is 0. Excuse me. Plug the other one in. 2 times 1/2 squared minus 7 times 1/2 plus 3. This is 2 times 1/4 minus 7/2 plus 3. Cancel, cancel. This is 1/2 minus 7/2 plus 3. This is negative 6/2 plus 3. Negative 6 divided by 2 is negative 3 plus 3, which is 0. Let's take a look at this one. All right, so this is factor. If it's going to factor, it has to factor like something like this. If I put the 2 here, I would have 10. One of these is positive and one negative. I'd have a 10 and a 1, and that subtracts to 3. So I can't do that, but if or subtracts to 7, not 3, or 9, not 3. So I need to put the 2 here so it doesn't multiply with the 5 and the 1 here. That gives me 5 minus 2. Minus 5 plus 2 is a negative 3. All right, and now I would complete this problem. X equals negative 2/5 or x equals 1. What if I want to do that exact same thing, but this time complete the square? Now this is a pretty ugly one. It won't get uglier than this to complete the square, but let's take a look at what we would do. Typically what you would do is move this 2 over to the other side. Then divide everything by the 5. So you get a leading coefficient of 1. Now I'm going to take half of this middle term and square it. So half of this is negative 3/10. And I'm going to square it, and I'm going to add that to both sides. So 9/100. So this is going to give me on this side and on this side 20 times 5 is 100, 20 times 2 is 40, so 49/100. And now I'm going to factor this. It's this term, this sign from here, the square root of this. Right, now I have a perfect square, and I can go ahead and solve it. That's called completing the square. Like I said, it doesn't get much uglier than these ones that have, fractions. So I'm going to take the square root of both sides. It's going to be a plus or minus. I'm going to have x minus 3/10 is equal to plus 7/100, or x minus 3/10 is equal to minus 7/110. Because square root of 49 is 7, square root of 100 is 10. Add the 3/10 to both sides. I get x equal 10/10, which is 1. Add the 3/10 to both sides. I get negative 7/10 plus 3/10, which is negative 4/10, which is negative 2/5. And we get the same answers as before. And the final way that I can solve this is using the quadratic formula. The quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. Right? So in this case, I have 5x squared minus 3x minus 2 equals 0. So my a equals 5, my b equals negative 3, and my c equals negative 2. So I have x equals the opposite of b plus or minus 9 minus 4 times a is 5 times c is negative 2 all over 2 times 5. X equals 3 plus or minus 9 plus 40. That's 20 times 2. Negative make a positive. All over 10. X equals 3 plus or minus the square root of 49. All over 10. 3 plus or minus the square root of, square root of 49 is 7. All over 10. So we have 3 plus 7 over 10, or 3 minus 7 over 10. So 10 over 10, or negative 4 over 10. So 1 or negative 2/5. All right, there we go. I think consistently the most difficult thing for most people is the part about completing the square. So when you have a plus b squared, you end up with a squared plus 2ab plus b squared. So when you are trying, you'll notice that if this is just an a with no term in front, if you take half of this term and square it, you end up with this b term if you just ignore the a. So that's why we do that. So let's just take one from the textbook here, number 57. All right. So what I would do is I'm trying to get this like perfect square. I'm trying to complete the square. Move the c over there. I don't really need it right now. And divide by the 2 to get me just with a leading coefficient of 1. So I divide everything by 2. So now I take half of this, which is 2, and square it, which is 4. And I add it there. Now this is in this perfect square form. I can't just add 4 to one side and not add it to the other side, so I have to add it over there too. Right. So that's how come I can just add something, is because I balance the equation by just adding it over. Now, this is your a term. This is a positive, so it's going to be a plus. And then half the square root of this was 2. That's going to equal your 9/2. And from there, it's just a matter of square rooting both sides. Right? And subtracting. Now, we try not to leave radicands in the bottom, which we'll talk more about in the next couple chapters. So I can multiply the top and bottom by the square root of 2. That will leave me something looking like that. Right? So that's how I could solve that equation, completing the square. All right. And I will wrap this one up for now and look forward to talking to you on the next one.